Alright, so as we get started with inverse trig functions, if you're out there, if you would type in the chat, what are some things that you know about inverse trig functions? So I see they're a reciprocal of a okay, so they're not a reciprocal. Our reciprocal functions, that's something else. So like cosecant is the reciprocal of sine. So reciprocal functions, that's a whole nother category. So they reflect over the line y equals x, very true, okay? When they're composed with the original function, the result is x. So some things about inverses in general, right? Graphically, they reflect over y equals x, right? F composed with f inverse of x is equal to x, as well as f inverse of x composed with f of x is equal to x. That is true. There is a button for that on the TI-84 calculator. That is a true thing. We'll be looking at that. What happens to your domain and range? Or your input and your output? Okay. So the domain and range swap, right? Okay, so if you remember, in order to be a function, a graph has to pass the vertical line test. So in order for the inverse to be a function, it has to pass the horizontal line test, right? So let's start with sine. We're going to go ahead and just graph sine of x here. We want to go a little bit on the negative side. So we're going to get pi over 2, and pi, and 3 pi over 2, 2 pi. We'll go ahead out to 5 pi over 2, 3 pi, 7 pi over 2, 8 pi. We'll go over here, negative pi over 2, negative pi. You should be getting pretty proficient at counting by pi over 2s, making those equal intervals on your graph. We'll go to 1 and negative 1 on our y-axis. And so our sine, remember our sine starts at 0, goes up to 1, goes down to 0, goes to negative 1, goes back to 0. That is one cycle around the unit circle. It produces a hill and a valley. And then we go back up to 1 and 0 and negative 1 and 0. And our wave repeats for another period length. Right? Over here, we'd be down at negative 1, at 0. So we've got this great looking sine wave going on. And obviously it is a function. It would pass the vertical line test, right? I can draw a vertical line anywhere and it will only pass through one point. But obviously if I go to draw a horizontal line, dun dun dun, that's going to fail a horizontal line test. So sine doesn't have an inverse, or the inverse of sine isn't a function all the way across, right? So this is sine x. Right? What's that?
I said, therefore, the cosine function also does not have an inverse function.
That will be true. The same is going to be said of cosine. So, sine of x, it has an inverse, right? But that inverse is not defined as a function because it would fail the horizontal line test. But we want there to be an inverse that's a function. And so what we're going to do is we're going to restrict the domain. So what we're going to say is, let us only look at negative pi over 2 to pi over 2. Let's only look here on our x-axis. So if we restrict our domain, we're going to restrict the domain of sine x. to be negative pi over 2 to positive pi over 2. So we're saying, yes, we know the sine is a wave. It's going to go up and down and up and down, and it's not going to have this one-to-one relationship with its inverse. But what we're going to do is we're going to ignore everything else except for this section right here. And if we just look at this part, now it passes the horizontal line test, right? And so for this part right here, the domain is negative pi over 2 to pi over 2. And the range, right, is negative 1 to 1. So then our inverse sine function, which we write like this, it's sine, and then there's a negative 1, and then an x. So this is the inverse sine x. And it also goes by another name, and that is arc sine. So these are synonyms. So inverse sine, arc sine, same thing. So remember, in inverse functions, your domain and your range swap. So for the inverse sine or the arc sine, the domain would be negative 1 to 1, and the range would be negative pi over 2 to pi over 2. So now we're looking at sine as a function, looking at it on a coordinate plane, xy graphing. But now we want to tie it back into our unit circle. So on our unit circle, if I want to show the domain going from negative pi over 2 to pi over 2, remember, when we go clockwise, we're at negative. So negative pi over 2 would be here. And then pi over 2 is up there. And so that domain is going to be there in the first and fourth quadrants. Right? Quadrant 1 and 4. So the inverse sine is going to exist in quadrants 1 and 4. Alright, so let's go through calculating some problems with this. Alright, so number 1, example 1. If I want to take the inverse sine of 1/2 and say that that's equal to x. So what I'm actually saying here is x in this case would be an angle, right? And so I am looking for the angle that has a sine of 1/2. An angle with a sine of 1/2. So, if I'm only going to be in the first and fourth quadrant, remember, sine is positive in the first quadrant, and sine is negative in the fourth quadrant, right? Because your sine is your y value. Right? So y is positive in the first quadrant, negative in the fourth quadrant. So I'm looking for a positive 1/2, so I know I'm going to be up here in the first quadrant. And hopefully you have not forgotten everything about your unit circle. Now, sometimes I forget, but I remember that square root of 2 over 2, that's for my pi over 4s. Like, hopefully you've got that down. That's pretty easy. And then I know that I've got 1/2, and I've got square root of 3 over 2, right? And sometimes when I haven't been doing trig for a while, I do kind of forget which one goes with what. And when I do that, here's how I think about it. My sine is my y value, right? So I've got a triangle that goes there, and the sine is short. And then I've got another triangle that goes here, and the sine is longer. So 1/2 is shorter than square root of 3 over 2. Because the square root of 3 is larger than 1. So this is smaller. So that means I'm looking at this guy right here, because my y value is smaller. And so that's at pi over 6. So the angle whose sine is 1/2 is pi over 6. All right. Next example with sine. Arc sine of negative square root of 2 over 2. So one thing is to just get used to, if you see the sine with the -1, that's inverse sine. You see arc sine, that's inverse sine. They are the same thing. I'm going to alternate using them so that you get used to both. So this I know relates to having a 4 in my denominator. But I need the angle whose sine is negative square root of 2 over 2. So again, looking at my unit circle, if I'm only going to look in the first and the fourth quadrant, I have to be down here in the fourth quadrant because I need my y to be negative. And instead of going around the unit circle and finding out what this value is, remember I'm looking at going from negative pi over 2 up to pi over 2. So this point right here, when we did our unit circle and we went around counterclockwise, we said that would be 7 pi over 4. But that's not what we're going to put for the answer for arc sine, because in arc sine, I want to be in between negative pi over 2 and pi over 2. So I want to look at going clockwise. 7 pi over 4 is coterminal with negative pi over 4. Right? So coterminal, meaning they have the same ending space. So going around like this and landing right here, that's 7 pi over 4. Going clockwise this way, that's negative pi over 4. I want the value that's in between negative pi over 2 and pi over 2. So if I say that that equals x, x would equal negative pi over 4. And we say it's coterminal with 7 pi over 4. All right, one more example with inverse sine. So example 3, if I had the inverse sine of 3, I'll say equals theta. Remember, theta, we are looking for an angle here. So sometimes you might see a theta there instead of an x. So I'm saying I need the angle whose sine is 3. Well, wait a minute. Sine only has a range of -1 to 1. So does sine x ever equal 3? No. So this does not exist.
would that be like the circle with the line through it?
I suppose you could put that. It's probably better actually just write that it doesn't exist. Only because that symbol means something a little bit different in set theory. And especially for those people, for when you're studying statistics. Alright, so there's everything with inverse sine. Let's look at cosine. Now, Soren has already mentioned that we know cosine is also a wave, and so we are going to have to restrict its domain. So again, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Alright, we go from 1 to negative 1. Cosine starts up high, goes to 0, goes to negative 1, goes to 0. Who's on here? And then at 2 pi, we're back to 1. Right? And remember, this is not like a V, right? It curves. So there's a curve. And we curve, and then we curve up into the next hill. Then we're going to continue down to 0, to negative 1, to 0, to 1. We curve. We're just making our little wave here. So we can see that this would not pass the horizontal line test. So the inverse is not a function if we look at the whole domain. But we just wanted to restrict a piece of it. So if we restrict cosine from here to here, from 0 to pi, if we just go from 0 to pi, we'll be safe with the horizontal line test. So for cosine, we're going to restrict the domain to go from 0 to pi. Sorry, bracket.
Miss Collier?
Yes.
How do you determine where to restrict the domain?
All right, so that's a good question. So we could say 0 to pi, right? But well, somebody else could say pi to 2 pi. That would work, right? Somebody else could say 2 pi to 3 pi. And the thing is that if you did that, it's not like you would be correct that now it's going to pass the horizontal line test. But if we're all talking about the inverse of cosine, and we have all these different restricted domains, it's going to be very hard for us to talk to one another. It's going to be very hard for scientists to share work and ideas. So we have to standardize things. And so we are agreeing to go from 0 to pi. Now, why did we choose that one? Because we're choosing what's closest to the y-axis, right? And so for sine, we chose to go like this because that included the y-axis. And then the other part why it makes sense to choose that is because when we go to the unit circle, and we go from 0 around to pi, we get the first and second quadrants right there. So, because this is a wave, it is true. We could decide to restrict it to a different domain, but we have to be in agreement with everybody else who's studying math everywhere else. And so this is the domain that we choose.
Okay. Thank you. That makes
You're
more
welcome.
sense.
And so cosine, so remember, cosine is your x value, right? And so cosine is positive in the first quadrant and it's negative in the second quadrant. So again, we'll do 3 examples with a cosine. So example 1, if I wanted the inverse cosine of negative 1/2. So I'm looking for the angle whose cosine is negative 1/2. So it's going to be an angle in my second quadrant, right? And the cosine is 1/2 as opposed to square root of 3 over 2 on my 3 is my denominator, right? So if you remember your unit circle, you've got pi over 3, and then you've got 2 pi over 3. Both of these have cosine worth 1/2. This is positive 1/2. This would be negative 1/2. So our answer here is 2 pi over 3. And if you're feeling really lost about this, it means you need to go revisit your unit circle. Alright, so what if I wanted to find the arc cosine of negative 2? Alright, remember arc cosine is the same as inverse cosine, it's just a different notation. These mean the same thing. So I'm looking for the angle whose cosine is negative 2. Does cosine ever go down to negative 2? No, does not exist. Alright, example 3 on cosine. What if I wanted the inverse cosine of negative square root of 2 over 2? So I want the angle whose cosine is going to be negative. So it's going to be over here in the second quadrant. Square root of 2 over 2, that's my multiples of with 4 on my denominator. So I know this is pi over 4. 2 pi over 4 is pi over 2, so that's 3 pi over 4.
Are we going to graph these inverse functions?
Just a little bit. We're not going to do a whole bunch of transformations. Alright, so next we're going to look at tangent And so instead of graphing tangent out, I just wanted to put tangent here on your graphing, on the graphing calculator. So remember, tangent kind of has this S shape, but we've got asymptotes for tangent, right? So obviously, tangent would also fail the horizontal line test if we looked at the whole curve. But if we just looked at one of the S's, like from here to here, then that would be okay. So, for tangent theta, we're going to restrict it to negative pi over 2 to pi over 2. Now, notice here, the other ones I put brackets. Why do these have parentheses? Because remember, that's where your asymptotes are. Tangent of pi over 2 is undefined. So when we restrict it, it doesn't include those two asymptotes. And so on your unit circle, you're going to, from negative pi over 2 over to pi over 2. So you're looking at quadrants 1 and 4, very much like we did with sine, right? We're looking at quadrant 1 and 4. And then if you've got sine and cosine down, you're probably good with transferring that information over to tangent. So now we want to get to the really fun stuff, which is composite functions, doing more than one function. All right. So I want to take the sine of the inverse sine of 1/4. So remember that inverse functions, they undo each other. And Declan reminded us in the very beginning that if you compose the original function with its inverse function, you get back to x, right? So the sine of the inverse sine of 1/4 would just equal 1/4. So this part here, the inverse sine of 1/4, there is an angle that exists where the sine of that angle is 1/4, and then I'm going to take the sine of that angle, and so of course it's going to be 1/4. Provided that this number here is in my domain. So remember, for inverse sine, the domain of the inverse is the range of the original. So the domain here goes from -1 to 1. And 1/4 is in between those two. So then, yes, that works out. But if this had said sine of inverse sine of 2, the inverse sine of 2 wouldn't exist, and so then you wouldn't just put a 2 there. So you have to make sure that this is in the domain in order for that to work out. All right, so let's look at another one. Show you kind of what I was just saying. The arctan of the tangent of pi over 2. So at first you just think, oh, inverse tan and tan, get x back out. But does the tangent of pi over 2 even exist? Remember, that's where your asymptote is. Remember what tangent means? Tangent of theta is sine theta over cosine theta. So if you're at pi over 2, you're looking at sine of pi over 2 over cosine of pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 divided by 0 is undefined. So tangent of pi over 2 is undefined. So the inverse tangent of pi over 2 does not exist. Alright, so now I want to take the arc sine of the sine of 7 pi over 4. So the sine of 7 pi over 4 that's negative square root of 2 over 2, right? So the angle whose sine is a negative square root of 2 over 2, you might think, well, it's just going to be 7 pi over 4. Yeah, but 7 pi over 4 is not in our domain. That's restricted. So if I'm here and I go around this way, that's 7 pi over 4. But I need it to be coterminal with 7 pi over 4, but I need it to be in between negative pi over 2 and pi over 2. So it's actually going to be negative pi over 4. Coterminal with 7 pi over 4. Has the same ray, right? But negative pi over 4 is inside this restricted domain, whereas 7 pi over 4 is not. So the answer to this is negative pi over 4. Alright, last example. Okay? I'm going to get into one. You might think, oh, now we're getting really tricky. But it's just a matter of taking all the things we've learned and putting them together. Right now, we want to find the cosine of the inverse tangent of negative 3/4. So I want to take the cosine of the angle whose tangent is negative 3/4. So let me go to my unit circle. Tangent is defined, inverse tangent is defined right there, my first and fourth quadrant. And so if it's negative, that means it's going to be down here, somewhere in the fourth quadrant. Right? Somewhere like that. So I'm going to take that triangle and pull it out. Right? So it's a triangle with a right angle, and this is my theta. Now this goes back to your right triangle trigonometry, right? Do you remember that tangent of theta is opposite over adjacent, SOHCAHTOA? So if this is theta, opposite over adjacent, so I've got 3 and 4 as my lengths of my triangle. So This part right here is theta. This is the angle whose tangent is -3/4, is this angle. And then I want the cosine of this angle. So the cosine of theta is adjacent over hypotenuse. Oh, well, the adjacent is 4. Oh, well, what's the hypotenuse? We don't know. But we can find out, right? Good old Pythagorean theorem. A squared plus b squared equals c squared. 9 and 16, 25. Square root of 25 is 5. 3, 4, 5 is the most common Pythagorean triple, right? But if you don't know that, you can go through all the steps of the Pythagorean theorem. So this side is 5. That's the hypotenuse. So the cosine of theta is adjacent over hypotenuse. So it's going to be 4 over 5. Now the only question is it going to be positive or negative? Well, where are we at here? We're in the 4th quadrant. Cosine is your x value. That's a positive value. So there we are, 4/5.